This lecture will talk about the software side a little bit, specifically how the software is processed before it's actually executed in the microcontroller. So key here is that the code that you actually write isn't literally processed by the microcontroller. It's not executed directly. It has to be processed first, compiled or interpreted, and then it's processed. So we'll talk about that. Software translation. So in the end, a microcontroller, or CPU as we're calling it right here, microcontroller, it doesn't understand C or C++ or Java or Python or any of those languages that most humans program in. It understands its own machine language. So take an Intel processor. It understands Intel machine language, x86 machine language is called. So different processor families understand their own machine language. Now, machine language is basically a set of really small, simple instructions encoded in binary, zeros and ones. So if you ever look at machine code directly, all you see are zeros and ones, or typically people, when they view it, they look at it in a hex editor. So they see zeros and ones represented in hexadecimal. So, but it doesn't look too readable. Basically, it's a string of characters, 0 through 9 and A through F, right? And you just see them in pairs. So it's not easily readable, but that's what the machine actually executes, is this machine code, which is an encoding of very simple instructions: add, subtract, multiply, very basic instructions. Now, above that is what's called assembly language. Now, assembly language is basically a one-to-one mapping from the machine code that's actually executed to a mnemonic, a simple mnemonic that a human can read. And now, it's not easy to read, but it's easier than the zeros and ones. So instead of having a sequence of zeros and ones, assembly code will say add R1, R2, R3, something like that. So that's readable. But still, it's very low level. These instructions are very simple. You can't have for loops or any of the common constructs that you have in programming languages. You can't use any of that. These are very simple instructions. So assembly language to machine language, they are a one-to-one mapping, right? You have an assembly instruction. It is exactly equal to a machine language instruction. So it's very simple, but at least it's readable. It's in some sort of English-like format. So you can write an assembly language, but it's hard, and we're certainly not doing it in this class. People do it sometimes for certain purposes, but we're not doing it in this class. What we'll work with are high-level languages, what we'll call high-level languages. The commonly used languages: C, C++, Java, ... Python, which is what we're going to look at. We'll focus on C, C++, and Python, but there are many high-level languages that people program in. So these are much easier to use. They give you the regular programming constructs that programmers are used to, loop constructs, variables, structures, objects, things like this. So those languages, high-level languages, are what we're actually going to code in. But that's not what's actually executed. The machine language is what's actually executed. So this high-level code, high-level language that you write in, it has to be converted into machine language before execution. So all the software that you write in a high-level language has to be translated into machine language, into the machine language of the microcontroller, before you can actually execute it. So there's always that process. You're going to write the code, then you're going to do the translation, and then it gets executed. Now, there are two ways this can go, depending on if it's a compiled language or an interpreted language. So compiled language, what happens is compilation happens where the language, the instructions get translated into machine code before execution one time. And you get what's called an executable at the end, which is basically the machine code and plus some extra data, but essentially machine code. And this executable is what is run every time you run the code. So the compilation, the translation from the high-level language to the machine code happened one time before you executed it. And then every time you execute it after that, you don't have to do that conversion. Okay? So compiled languages include C, C++, Java halfway. There are other languages, too, that are compiled languages. So when we work with the Arduino, we'll be working in C++, essentially. So that's a compiled language. So this translation, this compilation process, it happens once. Realistically, it happens many times because you compile it, and then you realize you had a bug, and you fix it, compile it again. But essentially, you finish compiling it, and once you're done and it works, then you never compile it again. You just execute it. Okay? Now, as compared to compilation, there's also interpretation. So you can have an interpreted language, like Java, Basic, Visual Basic. Python is an interpreted language. or a scripting language, but also interpreted language. So in interpreted language, what happens is the instructions, the Python instructions, let's say, are converted into machine code at runtime. So every time you execute that code, you have to convert the Python into machine code. Unlike with the compiled language, right? Compiled language, you compiled it once and you got the machine code, and then every time you executed it, you didn't have to compile again. But with interpreted languages, you have to compile every single time. Or you call it an interpretation, but it's the same thing. You have to convert into machine code every single time. Now, there are advantages and disadvantages. The disadvantage is that it's slow. Compared to compiled code, it's slow because you have to do that whole conversion from high level to low level every single time. But it has a lot of advantages because it allows you, as a programmer, it relieves you of certain burdens. So certain things the programmer doesn't have to think of because the interpreter will deal with them. So for instance, just as an example, let's say in C, you're using a variable, you're defining a variable, an integer, right? In C, if you want to use an integer, you have to declare that integer. You have to say int x, let's say. And you have to put that at the top of your code so the compiler can know, oh, he needs an integer, an x, right? And with an interpreter, like with a Python language, you don't have to declare x as an integer. You can just start using a variable called x. And the interpreter will figure out, oh, I think he means for this to be an integer. I'll refer to this as an integer. Or if it sees you're using the variable differently, it'll make it a floating point or something like that. But that's a burden that the programmer no longer has to deal with, right? The interpreter at runtime can figure out what the type is rather than you as a programmer have to deal with it. So interpreted languages do have the advantage that they are generally easier to program in, but they are slow. Thank you.